claim their residence is somewhere else. Yeah. It's based on the district of the secondary school, of the primary school they're enrolled in. Now, if you can, in standard 8, if you can move from Nairobi back to a primary school somewhere else where the threshold is lower, it would be easier to get into a national. So maybe that's what you're alluding to a bit, where people can portray themselves as not really being from Nairobi, but being somewhere where the threshold is lower. Is that what you're alluding to? And certainly in standard 8, there's a fair amount of shifting across schools, which can be strategic. So then you count as whatever the district is of the school you're attending in standard 8. That's what's in the data, and that's what defines your threshold. That's how it works in the computer. So basically, in addition to getting the data, Isaac got the computer program that does this. So he knows exactly how it's done. So my understanding is that's how it's done. But of course, that opens up tremendous incentives to move to a poorer district in standard 8. Yeah?
Does the 90%, 97% match number mean that there's only a 3% dropout rate? Or?
No, I think among the people with the score, so who didn't drop out, he was able to match their ID and their name back to KCP. That means in 3% of cases, maybe there was a typo, or the IDs didn't line up, or the names changed, or something. But I think that's conditional on taking the KCSE. That's my understanding of the data when I was reading the paper. Was there a hand up the back? No. Okay, so how does it work? And this is the question we just got, which is, what happens when you're admitted? So what Lucas and Beeke do is they create this variable, which people, when they're using regression discontinuity designs, call the running variable. The running variable is this kind of continuous score in which you define a threshold. There's some threshold level in the running variable. Now, what's interesting, and the running variable here is your KCPE score for an individual minus the cutoff of the national school you applied to. That's what's relevant, because even if you might have gotten into some national school from your district, what's all that's relevant are the 2 national schools you applied for. So they actually create the running variable this way. So a 0 here means you have exactly the score you need to enter that school from your district, given your gender, basically. So everybody greater than 0 is admitted. Everybody less than 0 is not admitted. And one of the things you can see here is, going back to the very good question before and saying, like, what happens if you get in but you can't afford it? You can see if you go above 0, 70, 80% of people really do graduate from a national school. So it is the vast majority that do. It's not 100%, but some of that may not be payment related. Maybe that you dropped out, or you have good scores or something. So the vast majority of people who are admitted attend. And of course, for the people that are way above the cutoff, like the really strongest students, that relationship is even higher. I mean, you're getting almost 100% completion. Now, below the cutoff, the rates are really low. So if you go 30 points less than the cutoff, basically you have no chance of graduating from a national school. But as you get closer, it sort of inches up. So one interpretation of this, and this is really what Lucas and Beatty say in the papers, like if you're pretty close to the threshold, your chances of kind of sneaking into that national school when there's a little bit of turnover in the first semester or two isn't terrible. Like maybe you have a 10 or 20% chance of getting into a national school because you're really close. Imagine I was really close to the threshold. I'm from Nairobi. I have a really high test score. I'm a really good student at this national school, and they really want a very strong student who score my score. If I'm the marginal student from Nairobi, Lucas and Beatty say this, the marginal students from Nairobi very often have test scores way above the average for the national school because of the quotas that are given to all the rural districts. So the headmasters may really like to bring me in. So you have a decent chance if you're really close, but even if you're 10 or 15 points away, your chance is pretty small of getting in. And this suggests that, look, like the headmaster has some leeway, but it isn't like they can be bringing in people with very weak scores. Like that would raise red flags or kind of set off, maybe political issues, or there'd be more scrutiny of what they're doing. What else do people see when they look at this figure? Any other patterns? Yeah. Yeah. Yeah, I noticed that too.
Why is that? Is that just because I got this just a coincidence that all of those students have?
So they don't in the paper, and I reread it again. I read it closely again last night. I don't remember. I was looking at that. I didn't remember them saying anything. So I don't think they gave an explanation for it. Can anybody think? Yeah.
Well, is the KCSE score needed if you're intending to go to a different type of university? I mean, you figure some of these people with extremely high scores and then they're also doing extremely well, maybe they're getting background. They might not worry about Kennedy because they're going to Princeton.
Well, that's really interesting. So to the extent that like the top students maybe come from well-off backgrounds and they switch into these international high schools, or they end up going to boarding school in England or something like that, then maybe they don't finish at a secondary school, not because they're doing poorly, but because they're like so elite that they can afford an even fancier school or something. So that's one possibility. Did you have another? Was that your view?
And also, if you're really, really smart, you might just not want to follow the rules. Like the evil genius.
Okay. Are there any evil geniuses in this room? Please raise your hand. I need to know right now. Uh-oh, I saw a hand going up back there. Okay, so that could be part of it. The other issue that came to mind a little bit for me, and it's not a perfect explanation, as you get to the real extreme of the distribution here, you have fewer observations in each of these dots because they're defining the dot by like the points you're at. And so if you only have 15 observations in one of those dots, it's going to kind of be a noisier measure because of sampling variation. Now that wouldn't explain why they're all lower, right? But it might just explain there being a little bit more variability due to less mass, there in the distribution. But this other issue about the top students maybe having even higher quality options, I think, is not to be discounted. And the notion that maybe the top students just do other stuff can't be ruled out. There was a book that came out about the life of Barack Obama Sr. And Barack Obama Sr. was actually at a very elite high school, like one of these national schools in Kenya, at the very end of the colonial period. And in his last year in high school, he was actually kicked out of the school for insubordination because he was challenging his teachers. He was like really one of the top students in his school, and he had been sort of insubordinate, got in trouble with his teachers many times. They overlooked it because he was such a good student, and eventually he was thrown out because he was like openly disagreeing with teachers in an era where not everybody was as sort of warm and fuzzy as we all are now. So maybe there's something to that too. Okay, what is the regression discontinuity estimate? The jump. Remember we talked about the jump last time. I was just sketching it on the chalkboard due to our technical problems last time. This is the discontinuity in the data. Lucas and Beatty estimate 3 things. They estimate the slope of this line to the left. In other words, that f of Ri, what is the slope in terms of graduation as a function of the running variable? That's one thing they estimate, that slope. They estimate a different slope on the right-hand side. That's another part of f of Ri, the slope of graduation with respect to the running variable. And they estimate the jump, the intercept. Those are the 3 things that come out of this regression. And the intercept gives you the discontinuity. And that discontinuity is basically 0.5. So the odds, if you're literally 1 point above the threshold versus 1 point below the threshold, that being above the threshold increases your odds of graduating from a national school by 50 percentage points. So 0.5. That's a big effect. It's not 100%. It doesn't literally go from 0 all the way to 100, but 0.5 is pretty good. 0.5 is pretty good. People have any other thoughts kind of staring at this figure a little bit? Yeah.
It seems to me that on the left-hand side, there are many people who are very capable and should graduate. Only say at the top rank, only about 20% of them graduate. That's very low.
This is graduating from a national school. Yeah, so this is really just saying how much value add you get from national school. Presumably these guys are very strong students and they're going into very good provincial schools. And that's actually another part of the story Lucas and BT bring in, which is to say that like the provincial schools in the richer areas are really good because they're getting people who can't get into the national schools because of these very high thresholds, whereas the provincial schools in the poorer, more rural areas are much worse. So the kind of gap in the educational quality you may get by going to a national school is just going to be much larger if you're coming from the northeastern province, which is very rural and poor, versus Nairobi. So presumably almost all these guys are graduating from secondary school but at a different non-national school institution.
I don't see how this is supposed to tell us.
Does someone have an answer or thought for that? Yeah.
This is just a test for the crispness of the RD, right? The actual legitimacy of the
Yeah, so if there were no jump, it would say, look, regardless of your test score, you kind of have equal odds of going to a national school. So kind of comparing the people just to the left and the right isn't giving you any treatment. What this is saying is going from right here to right here, these guys' test scores are almost identical. I mean, literally 1 point difference or 2 points difference out of 500 points. But if you literally move those 2 points, now you have a 50 percentage point greater chance of being in a national school rather than a provincial school. And they want to ask the question, if you get into that national school, do you do better on tests? So that's the reason for this. Now, again, there's like a very, very clean RD, exactly as alluded to, would look like this. 1 here, 0 here. And then you could say, like going, this is the threshold, here it's called 0. This is the running variable. There the jump would be 1, like perfect difference. So this is like imperfect treatment assignment. That's one way to think about it. And that's where this paper links to the instrumental variables literature. I'm not going to talk about IV today, but they do talk about IV in the paper in a very intuitive way. And they say like the whole point of instrumental variables is to find something that changes your odds of treatment, in this case treatment with going to a national school, but maybe imperfectly. So if you had a 0 or 1, you can compare like control versus treated. Here, you don't have 0 or 1. You have something that strongly correlates with being in a national school, but not perfectly. So once we're done with the midterm, we're going to go right into IV, and we may actually come back to this. This is a pretty good example of how you could use imperfect treatment assignment. Okay, so this is the regression version of that previous figure, and it turns out that the admitted to a national school dummy, which is basically dummy for being a 0 or above, is basically 50 percentage points, 49.7 percentage points, with a t-stat we'd all love to have all the time, t-stat of 25. So clearly there's an effect. That is a statistically significant jump, and you can see that in the data, but it's reassuring to see there. And you can see this is a pretty decent sample, even with this somewhat narrow band around the threshold. They still have 14,000 observations. This is the advantage of using national administrative data, and it goes back to some of the questions that came up last time about like when is RD useful? Well, RD is really useful when you have hundreds of thousands of observations because you can have a narrow window and still have 14,000 observations and get pretty tight standard errors on your estimates. So this is just a regression analog. I kind of put what they say about the different controls they have in there as well. Okay. So they do 2 other things. So before we get to the results, I want to talk about 2 of these other challenges of using RD. And again, they go through exactly the things we talked about last time. They're able to check for manipulation in 2 ways. The first is they're able to check for bunching. Remember last time we talked about how in this Colombian health insurance program, vast majorities of people in certain cities had exactly the score they needed to qualify for health insurance. We'd be really concerned with this data if everybody had a 0 or 1 on this running variable. Like they just qualified. Again, in this case, that's less of a concern because there's no absolute threshold for admission to the schools. There's just a certain number of slots. It's a little bit like the Girls Scholarship Program where like no one knew in advance exactly what the threshold would be, because no one knew exactly what the test scores would be out of a given district by gender, nor exactly which national schools everybody would rank as their preferred schools. So when the grading is going on, there's no way you could say like, oh, I'm going to grade this person's test score. I know them. I'm going to favor them. I'm going to make sure they get a 434 on their KCP because I know that's going to gain them admission. Because the threshold could be 436 or 430. No one knew for sure. So that's probably less of a concern, but they do that check. And the other thing they do is they look at the kind of limited other variables they have to make sure they're not jumping at the threshold too. They want to make sure people look very similar on both sides of the threshold. So let me show you the figure that does that. That's figure 5. The upper left panel is what they call the density of students. In other words, the number of observations that have a running variable score at minus 30, minus 29, minus 10, minus 9, minus 1, 0, etc. And why don't people look at that and then tell me what they think? Does that look good or bad for them, the data? Do you guys see that 1 point up there? Does anybody remember from the paper where that 1 point comes from? There's actually an explanation. That's at minus 1. Why is there a point at minus 1? Yeah.
Because the rest was an actual result of my step.
Yeah.
The one that's what was looking at running.
Exactly. Actually, so that's exactly 0, not minus 1. So it's exactly what you said, which is the deficit. So to create KCPE minus cutoff, they need to establish the cutoff. And the cutoff, exactly as you said, is defined as the lowest scoring person from a particular district and gender who was admitted to that school. Now, in truth, they might have been able to be admitted even if their score was 1 point lower or 1 point higher, but almost mechanically, there's a lot of people at exactly 0 because they're defining the cutoff based on that person's score. So almost mechanically, you're going to get this weird spike at 0. I see a lot of people going, oh, I see. Okay, so it's sort of weirdly the case that that's exactly why there's this mechanical thing. But minus 1, minus 2, plus 1.2 is totally smooth. It's just that they're defining the variable in this weird way. Let me pause and see if people have questions about that or if we should explain the intuition of that a little bit more. Yeah. Yeah, so that probably means there's 1,200 cutoffs, which kind of makes sense if you think about the fact that there's scores, dozens of districts, and about 18 schools and 2 genders. Maybe if you multiply those things together, you get something that looks like 1,200. I mean, it really depends on how you define the districts. Even between 2004 and 2008, there was a multiplication of districts in Kenya, but if there were roughly 50 districts, and maybe it could have been not even from every district people got into every national school, I'm not sure, but that's basically where it comes from. That's like the definition of cutoffs for each district, gender, school. Okay, so the other variables they have is whether you went to a public primary school or a private primary school, and then your age, because those are just things that are recorded on the official administrative data. It's very smooth around age. You can see the average age is around 17. There's some interesting things here, which is the better scoring kids tend to be a little bit younger, which you might think of as being counterintuitive. Why might that be the case? Yeah.
Parents are like comparing kids way over age.
Uh-huh.
So it could be possible that those students were like promoted in ways like during primary, that's why they got.
Uh-huh. Yeah, it could be the parents. And the other thing that's very relevant, which we touched on just briefly in talking about the Worms papers, there is a lot of repetition in Kenyan primary schools. So like the absolute strongest students tend not to repeat. They kind of get to standard 8 with the best scores without repeating, and the students that may be a little weaker may have repeated once, and so that could be part of the story. Also, remember, people are a bit older than we would think of when they're finishing primary school. So again, primary school is 8 years, And many people, and it's changing, people are actually starting, there's some data on this, starting primary school younger, but it was not uncommon to start primary school at all uncommon to start standard 1 at age 7 in the 1990s or something. A lot of these guys would have started rather than starting at age 6, for instance. And so if you start at age 7 and it takes 8 years and you repeat a grade, all of a sudden you're 16 or 17. So the numbers line up. But again, this is another reason why some of our intuition about this competition feels a little bit more like admission to university in the US if we try to do analogies, just because a lot of people are applying to college when they're 17 or 18, which is sort of close to this, this age group here. There's also, it seems like, quite a bit of smoothness around the proportion of students who finish public primary schools. So again, about half the students among this elite group actually went to public primary schools. It's between maybe 0.4 and 0.6 or something, or 0.7. And that's a downward sloping relationship. So in general, the highest scoring people went to private schools. Because again, there's some elite private schools. If you go farther down the distribution, remember I showed you those first two pictures of the distribution, most Kenyan kids go to public primary school. But in the right tail of the distribution, you get a fair number that went to private school. So maybe it's not even too different than, say, in the US for admission to college. Okay, so what are the impacts? Two main impacts. No impact on completion. So they actually know, even for the folks who didn't go to the national schools, they know if they successfully took the KCSE and graduated from secondary school. There's no effect of being admitted to a national school on completion. But again, maybe that makes sense because folks who didn't get into the national schools, went to the good provincial schools, they're good students, they finish high school. Maybe more surprising is that there's no impact on test scores. There's basically a zero, and we'll talk about what that means. One question, and this is something that's very important for any of you that are going to do impact evaluation work or work with data, is if you find an effect, a statistically significant effect, you have something to kind of talk about and run with and interpret and whatnot. If you find a zero, the first question that's going to be asked by anybody who understands statistics, anybody in a conference or seminar, is how precisely estimated was your zero? In other words, did you get a zero simply because you had so little data that your standard errors were enormous? So you can't reject zero basically because you don't have much data, or the data isn't well suited for precise estimation. Or do you have a zero with pretty small standard errors? So you can say, no, I have a zero estimate and my 95% confidence interval is pretty small. So I can actually rule out large effects. Large effects lie outside my 95% confidence interval. That's a very important question. They spend a little bit of time in the paper discussing that, but the basic point is, for most of their estimates, they can rule out effects larger than about 0.1 of a standard deviation. So remember, the rule of thumb is if you're like at 0.2 or larger, that's a pretty good size effect in the education literature. They can basically rule out effects, in other words, it doesn't lie in their confidence interval, effects larger than about 0.1 of a standard deviation. And 0.1 standard deviation effects are kind of medium to smallish. So I think most people would look at this and say, this is a pretty precise zero. If you can rule out a 0.1 standard deviation effect, then yeah, maybe you have a 0.07 or 0.08 standard deviation effect, but that's not a huge effect. That's nothing to write home about here. So that's very important. For anybody working with data, if you get a zero, you have to ask yourself how precise your zero is. So this is the same regression discontinuity plot, where this time the y-axis is the probability of graduating in 4 years. So did you finish secondary school, successfully take the KCSE after 4 years? And even among the guys at minus 30, almost 90% of them are finishing in 4 years, and maybe some of them will finish in the 5th year or something. Among the top students, the really top ones, plus 20 or plus 30, in some of those cells, it's 100%. I mean, that's what that sort of, see all those dots on the right, they're all the way at 100%. It's like, for the very, very top students, they're basically all finishing. Although again, we get this kind of funny pattern, that at plus 30, there's a couple of these lower points. And the question there is, are some of these folks the folks who are just such strong students, maybe from such rich families, that they were admitted to a national school, and then they switched to an international school or something else? Yeah?
They also be really smart ones graduating in 3 years. That's possible.
Oh, that's interesting.
Please write on there.
I think Isaac may only have the data for 2008. So that's kind of interesting. I don't know of too many folks that finish secondary schools in Kenya in less than 4 years, but if anybody would do it, it would be these guys. These are literally the top students in the whole country. And so that's pretty interesting. I don't know if he has the 2007 data to back match.
I think it also explain why there's that 97% match. I can talk about that. They use 2007 and match up with what we have.
Maybe, although I think he defined the match based on who was in 2008 and he back matched to 2004. So I think your explanation could explain this, but maybe not that.
I think for 2008 and back match to 2004, they graduated from primary school. None of this is possible.
Oh, that's interesting. You're right. So your explanation could work in that way. So maybe that's part of it. There's just these few what would be the example in popular culture? Yeah, this is just someone who finishes college at age 17 or something. Yeah. Yeah, I was going to say that. I was just about to say I just didn't know if anybody would even get that reference. Now that I'm 28, 29, I'm a little older, I just don't know what you guys, you youngsters know. Yeah.
But in the previous figures, they're just generally leveling out to the right side. So the samples drawn from the extreme.
Yeah. Yeah.
Good progression for me related to kind of lack of consistency on what on a number of measures. Or maybe people would, if we tested again, they would perform it more.
Yeah, regression to me is always an issue when you think of, say, outliers in a test. If we were to see that, I don't know if it would come through in this way, but it's an issue we should keep in mind with testing. And in particular, when people look at, say, school level test scores and thinking about regression to the mean, it's something that's actually very salient when you have small schools or small numbers of people in particular, right? So if you have only 5 or 10 people in a group and they have a very high average test score in period 1, there's a non-trivial chance that a very high test score is due to some randomness, sampling variation, and then you would see reversion to the mean. And maybe part of that sort of related sampling variation way out of the tail can explain these patterns if there's only 3 people in that dot. Because it's literally, these are people with literally the most extreme tests, there's only a few of them out there. So it's something to keep in mind. I think, yeah, something to keep in mind. Did you ever hand up? Yeah.
Actually, I have this. I might be 2004. Should I be 2008?
Okay, tell us. Listen, this is so great. Okay, the data is speaking. Come on, let the data speak. Tell us.
I'm not from my school.
Which school did you go to? National school? Which school did you go to? Okay.
So
They're not the one that had an airplane. Isaac says in the start that there's one national school that literally has an airplane for an aviation class, and if he's doing it to show how the national school. Keep turning about. Okay.
actually, not even to have to imagine from moving to different countries.
Yeah.
What people are doing that here, and then
Yeah. So Kenyan diplomats, so they're posted in Nairobi for some period, but then they move, and then where did you move? Did you move to another country?